Okay, guys, so page 63. So remember that organic compounds from last week must contain carbon. They have to have carbon, and they're normally going to be bonded with a hydrogen. They also may have oxygen, nitrogen, phosphorus, sometimes sulfur every once in a while, but they have to have carbon and hydrogen that are bonded together. Number 13 should be good to go. Number 14 is asking you about valence electrons. All right, next page. All right, page 64. Page 64, number 1, you have a time distance graph. Remember, if you have a time and distance graph, if the distance does not change, that means it's at rest. All right, number 11, remember your potential and kinetic energy. So when it's at its highest point, it's not in motion because it stops for a split second, and then on the way down, the further it goes down, it's at its fastest speed. So it's asking you at which one of those positions is it gaining potential energy. So which one is it getting slower because it's going up. So if it's gaining potential energy, it's going in this direction. Number 3 is asking you about which one of these answer choices does not, because it says except, does not an energy change from thermal to electric. Number 4, again, is a distance time graph. So if you're not real careful, you're going to miss this little part right here, because it looks, if you're not looking real close, like the graph just starts at 5, but it doesn't. It starts over here at 0 and goes straight across until it gets to 5, and then it goes up and over again. So pay real close to that. All right, number 5, it asks you when an unbalanced force is applied to an object, what does it do? So go back and look at your journal on Newton's laws of motion. Number 6 is talking about machines. In most machines, the largest force is applied. The largest force that is applied, it wants to know which of these forces, if you're dealing with the machine, is the largest force that is applied. So we haven't talked about these probably since 5th grade or so. So the effort force is the force that's applied to the machine. I need to go back and change that. The resistance force is the force that the machine actually applies to whatever the object is that's going to get moved. Number 7, you're going to use your formula, force equals mass times acceleration. I want you to notice in your chart right here that your acceleration, remember, is always in meters per second squared, and then you have your mass, okay? And your question is asking you for, oh, that's number 8, sorry, I'm getting ahead of myself. So number 8, you're going to use your formula for net force. So net force is mass times acceleration. So the acceleration, again, is in your chart right there, meters per second squared. And then your mass is also in your chart. And so you're going to find the force on both of those by using your formula chart. So you're going to have to work basically 2 separate problems and find the force of each one of those, because it's asking you how much more force is needed to move one car than the other. So you're going to have to find the force for both car Y and Z and then calculate the difference between those 2 forces. So don't forget to do that in part or you will not get the right answer. Again, force equals mass times acceleration on number 9. That's your acceleration. Sorry, remember acceleration is always in meters per second squared. And then number 10, a rocket shoots a small probe out of the solar system into space. And it's asking you about constant velocity. So constant means to remain the same. Remember, velocity means that it's not going to change speed or direction. It's going to basically keep doing whatever it was doing after it gets up there, in which case it's probably going to be orbiting in the solar system, or it's going to keep going through the solar system. So it's asking you which of those is going to cause that to keep going through the solar system after it has been launched from Earth. Page 66. All right, page 66 looks like a distance time graph, but it is not a distance time graph. So look over here. Instead of having distance on your y-axis, you've got meters per second. So this is speed, and this is time. So a speed in a specific amount of time is acceleration. So this is showing you acceleration. It is not showing you speed. So make sure that you make note of that, because remember, if it's a distance time graph, this is at rest. But if it's an acceleration, that's not what that means. It means something else. So you may have to go back and look at your notes for that. I apologize if y'all can hear shots firing in the background. My husband's trying to kill birds that ate up on my strawberry plants outside. It's a little redneck, but that's how we roll. Okay, again, force equals mass times acceleration. All right, page 68. You're going to need to remember your HR diagram. So remember, if it's up high on your HR diagram, it's going to be hot. That's wrong. If it's up high on your HR diagram, it's going to be bright. If it's down low on your HR diagram, it's going to be dim. If it's over to the left, remember where we have whites and blues, it's going to be hot. If your star is over to the right, where we have oranges and reds, it's going to be cooler. All right, number 7. Which gives a correct sequence of moon phases for 2 weeks following a full moon. So start with your full moon, and you're going to look at the next 2 weeks after the full moon. So remember that all of the phases, all 8 phases, take 1 solid month, which is 4 weeks. So 2 weeks is 14 days. So you're going to have to carry out your moon phases for 14 days. Remember, each moon phase lasts for about 3.5 days. So carry them out until you get to about day 14. All right, number 8 says wait. There are several other questions that say wait as well. So if it says wait, you can just skip them. You do not have to do the questions that say wait, because they were what we were about to get to before all this craziness started taking place, and I didn't get to see y'all anymore, which super sucks. All right, number 9 is a 7th grade question. It's talking about an aquifer. Basically, remember, aquifer is groundwater. Groundwater is under the ground, so it's basically asking you what happens to that groundwater under the ground if you're in a drought, but people still pump water out of it. Almost there. All right, page 67 is talking about the red and the blue shift, and I'm going to give you some more notes on that in a minute. I know that's probably don't remember that. So a red shift and a blue shift, one of them moves towards you and the other one moves away from you. And I'm going to give you some more notes, and then you can go back and finish that question in a minute after I give you notes for that. All right, number 2 is a moon phase questions again. So you're going to have to know how many days it takes to complete the whole lunar cycle, which should be 28. And then to get that answer choice right, you're going to have to know how many days are in March. And there are 31 days in March, because it tells that you have a new moon on the 28th of March, and it wants to know when you're going to have the next full moon. So you're going from new moon on the 28th to full moon. All right, number 3, you can wait on. Number 4, you're going to have to look back at notes in your journal on spring and neap tides if you don't remember. Number 5, you can skip. Number 10, you should be good with. Number 11, skip. Number 12 is on the red and the blue shift. And so I'll back up my camera so that you can see. And then I'll post a picture of this page later on with my notes so that you remember what red and blue shift are, because I know we didn't cover that just a whole heck of a lot. All right, guys. Let me know if you need any questions. Reach out to me. I'll help you with anything I can. I'm still missing you guys and wishing we were at school. It's kind of crazy. I didn't get to spend the last month with you. Should be the last 2 weeks of school should be the best 2 weeks of like the whole year. And I was really looking forward to it with you guys and looking forward to our field trips. So anyway, I'll see you, I guess, at graduation. So you are still having graduation, and you'll get some videos and some notes on that later on. All right, guys, love you. Hope you're having a good week.